Hello, this is Mr. Rasmussen, and this is Algebra 2, Lesson 84, Solutions of Equations. This one goes back through when you have two equations, such as on the bottom here. They have three possibilities. They could be either consistent equations, inconsistent, or dependent. Consistent means that if you graph them, they cross, or they have one set of coordinates, one x value and one y value, that they both share. Inconsistent means actually there's no set of coordinates that they both share. And then dependent means that they share all the same coordinates. We actually have two lines right on top of each other. So I'll demonstrate that through the graph and also through the equations here for today's lesson. First of all, consistent equations. And you see, if we were to graph this one here, we have this red line. If we graph the second one, then we have the blue line, and they cross, and henceforth they share the coordinate pair of x equals -1 and y equals 1, so coordinate pair of -1, 1. We can see that if we graph them. However, you don't have to graph it to be able to find out whether it's consistent. You can just solve it and see what you get. Now in this case, when we solve it, substitution would work really well, where we write out x plus 2 is equal to -x minus 1. So we substitute that in there. And then we solve it there for x, subtract a 2 from both sides, and we get -3. Add a 2x to both sides, it looks like we get 3x equals -3. Divide by 3, and x is equal to -1. Then we would plug that -1 back in, and -1 plus 2 obviously is 1. And anytime you do that with the two equations and get a set of coordinates, one x value, one y value, they are considered consistent equations. Let's look at inconsistent next. Inconsistent means that if you were to graph both of them here, there's the red line, and they run parallel to each other. There's no set of coordinates that they both share. Now you can tell this in the equations because they will both have the exact same slope. We have a slope of a positive 2 over 1 there and a positive 2 over 1 here. And since they're the same slope, they give us the same exact line, but they have different intercepts. This one crosses at a positive 2, this one crosses at a -2. Henceforth, you can just look at that and see same slope, different intercept. They are inconsistent equations. If you were to solve this through elimination or substitution, you would get a statement that is not true. You would get something like 5 equals 2, and we know that that is incorrect. Our last option is dependent equations. Dependent equations is where when you graph the two lines, they're actually right on top of each other and the exact same line. And that's illustrated here by this equation. As graphed out, it's the same line. They actually share all the same x and y coordinate pairs. We can see that in the equation. If you were to solve this out through elimination or substitution, it would actually give you something that is true. It would say something like 3 equals 3 or 0 equals 0, and would indicate that. But the easier way is to put them both in the slope-intercept. This one is there. This one we'd have to divide everything by 2, and if we do so, then we get y is equal to x, and then -4 divided by 2 is -2. We can see that they're the exact same equation. Same slope, same intercept. If you see that in the equations, then that is the indication that they are dependent equations. So those are the three. Your book in the lesson takes it just a little step further, and instead of going in 2 dimensions, such as the x and the y, they actually put it into 3 dimensions, and they show there how with 3 equations you could have consistent equations for an x, y, and z coordinate that they all share would be consistent. Or if you were to have like 3 pieces of paper all parallel with each other, that's an idea of dependent, the idea of inconsistent equations. And then if you were to have them, the 3 planes in geometry sense all kind of share a bind in that third picture at the bottom right, I believe that would be an indication of dependent there, if I've got that correct. But that's all kind of extra as they move that into a three-dimensional model there. If you'd like a much more detailed lesson on this, go and watch the Algebra 1 video for lesson 81, and I spend a lot more time explaining this, the three different types of equations to them as far as consistent, inconsistent, and dependent. Well, I think this should look somewhat familiar from last year in Algebra 1, but if you have any questions, please feel free to contact me. Have a great day.